Welcome. In this video, we will be talking about unit circle trigonometry. We have three major goals. First, we want to understand angles as rotations of a circle, with positive direction as being the counterclockwise direction. In the picture above, I have a circle with an initial point. This is always where we start. We'll be talking about measuring angles by rotating in the positive or counterclockwise direction. Our second goal is to understand the radian measure of angle, which measures the distance traveled around the circumference. So as I think about this point as it travels around the circle, the distance along this circle, if this is a unit circle, the radius is 1, so here's my radius. This distance that I travel will be my angle. If my circle has a different radius, we'll be talking about how I measure this distance in units of the radius. So if I take this arc length and divide it by the radius, that would be my angle. Our third goal is to understand the sine and cosine of an angle as the y and x coordinate of the unit circle. So here I have a point. The x coordinate of that point is the cosine of the angle, and the y coordinate of that point is the sine of the angle. And finally, our last example is we will be talking about how the equation of the circle, x squared plus y squared equals the radius squared, will be key to our understanding of the unit circle. And in particular, the unit circle will have radius of 1, so we have the equation x squared plus y squared equals 1. I wanted to use this bicycle wheel to illustrate the ideas of the unit circle. So I've got a circle here, and I've measured the radius of this wheel, and the wheel has a radius of 11 inches. I've attached a rope through the valve stem hole, and what I want to do is I first want to illustrate the idea of the circumference to the radius ratio. So we know my radius is 11 inches, and I've got my rope, and what I'm going to do is I'm going to wrap a rope around the circle, so that it has gone around one time. So this is one full revolution. Okay, so this rope from pink ribbon to pink ribbon corresponds to the circumference. Okay, what I'll do now is I'm going to measure the circumference. All right, so I'm at 68.25 inches, 68 and a quarter inches. And the radius was 11 inches, and so we can calculate the ratio of the circumference divided by the radius. So 68 and a quarter divided by 11 is 6.2. Okay? Now, it should be, if I could do a perfect circle and perfect measurement, should be exactly 2 pi. So 6.28 something after that. So I wasn't so far off, 6.2 instead of 6.48, or 6.28. And so that's the relationship, okay? What that means is if I were to measure off this radius, or this circumference in 11-inch increments, one radius at a time, right? So this length right here is 11 inches. The idea of radian measure says that this angle from the start point to here, that would be 1 radian. And if I did 2 of those lengths, so here, this would be 2 radians. And 3 radians, pi radians would be exactly half a turn. Okay? All right, so that's how we measure things in radians, is we measure how many radiuses around the circle we go. Next, I want to talk about how we rotate a point. Our points always start on the positive x-axis. I've got some rulers behind my wheel to illustrate my axes. So this is my x-axis and my y-axis. 11 inches corresponds to the point where my circle crosses those. That would, in our measurements, be the position 1. So this would be 1, 0, and this would be 0, 1. All right, so I always start my circle at 0, or x value of 1, y value of 0. And I think of that as the sun rising in the east, so the sun is going to rise in the east. This is the direction of positive angles. So positive angles are counterclockwise, and as I turn, I'm measuring my angle. So if I wanted to measure 45 degrees, I start here, and I turn it 45 degrees in the positive direction. Okay. All right, so let's talk about some important angles. 0, of course, is right here. Pi, that's a half of a turn, is all the way over here, because 2 pi, I've completed a full circle. And if I kept going, 3 pi, is all the way over here, and keep going around again, 4 pi. So you'll notice that I keep returning over and over to my points. This is what it means to be periodic. All right. This vertical point is halfway between 0 and pi. This is pi over 2. And if I go the other direction, this would be negative pi over 2. And notice I can get there in two different ways. I could go pi over 2, pi, 3 pi over 2, or I could have gone negative pi over 2, or I could go negative 1, 2, 3, 4, 5 halves pi. Okay, so there are infinitely many ways of getting to each point. All right, so once I know how to turn my circle, the next question is, what are the sine and cosine? So the sine and cosine correspond to the coordinates of this point. So if I start at an angle 0, my x-coordinate is 1 and my y-coordinate is 0. So those have names. The x-coordinate is called the cosine of my point. So it's the distance horizontally to the point. The sine is the distance vertically to my point. So this has a cosine of 1 and a sine of 0. As I turn, notice now my cosine is this x-coordinate and my sine is the y-coordinate. So if I look at this point right here, let's lock it in. So this x-coordinate is at about 9 inches, so 9/11 is this x-coordinate. And on inches, my height is about 7, and so in radiuses, that's 7/11 is my y-coordinate. So my cosine is 9/11 approximately, and my sine is 7/11 approximately. Okay? So the x-coordinate and the y-coordinate give me my sine and cosine and my sine values. When I get to pi over 2, that's 90 degrees, notice that now my cosine is 0 and my sine is 1. When I get to pi, my cosine is as far over this way as possible. It's negative 1 and my y value is back to 0. So my cosine is negative 1 and my sine is 0. All right, so as we talk about the unit circle, I don't want you to memorize the special angles of 30, 60, 45 degrees. Instead, I want you to focus on this idea that there's a circle. I measure an angle starting at the positive x-axis, and wherever that point ends after rotating it, then the x-coordinate is the cosine and the y-coordinate is the sine. And I'm going to use an equation to find those values because this equation of a circle is x squared plus y squared equals 1. All right, so in summary, the angle measures how far around a circle we move. You might be used to thinking about measuring angles in degrees. For example, if this was time for the Winter Olympics, we might be talking about snowboarding and how they do 1080s or They measure how many rotations that someone does based on the number of degrees. So traditionally, this travel around a circle is broken into 360 equal parts called degrees. 90 degrees is a quarter of a circle, and so that's a quarter turn. And 180 degrees, that's a half a rotation. So the radian measure of an angle is based on measuring the arc length, which is the distance traveled around the circle. For a full rotation, arc length corresponds to the circumference. We measure the distance in the units of the radius. So if I have 1 radian in rotation, that corresponds to moving 1 radius around the arc of a circle. In our example with the bicycle wheel, if I took that rope that represented the radius and measured the length of the radius, and I wrapped around, so let me quickly draw a circle. So here I have my circle. I've got a radius that I'm going to call 1. And if I walk around the circle this distance, my radius, and I walk that distance around my circle, 1 on the arc length is somewhere around this angle. Okay? And so this would be 1 radian as my angle. A 2 pi radian rotation means I go 2 pi radius around, and so that corresponds to a full circumference. We can calculate an angle in radians by measuring what fraction of a full rotation we have. So here are 3 examples. 45 degrees, if I calculate a fraction 45 out of 360, that's 1/8. So that's an eighth of a full rotation. This angle would correspond to, my angle in radians would be 1/8 of a full rotation. A full rotation is 2 pi, and so 45 degrees corresponds to pi over 4 measured in radians. Our second example, 60 degrees. 60 divided by 360, that's 1/6 of a full rotation. And so the angle that corresponds to 60 degrees in radians is equal to 1/6 of a full rotation. That's 2 pi radians. And so that's pi over 3 measured in radians. Our third example is 90 degrees. And so a 90-degree rotation, that is equivalent to 1/4 of a full rotation. And so in radians, my angle is 1/4 of 2 pi, or pi over 2 radians. Now, we usually think of radians as the natural unit, and so we would not normally put radians in as a unit. It's just a pure number. We say, for our first example, theta equals pi over 4. The second example, theta equals pi over 3. And the third example, theta equals pi over 2. All right, the unit circle allows us to define our trigonometric functions. And so now we're going to introduce unit circle trigonometry. So a unit circle has radius of 1, which means that the equation for my circle is x squared plus y squared equals 1. If I consider a point and I rotate it by an angle of theta, so notice I've measured along the arc, this is a unit circle, so I've measured up theta units in distance. This point is now at some coordinate. The x coordinate is the cosine and the y coordinate is the sine. Because the unit circle's equation is x squared plus y squared equals 1, and x is cosine and the y is the sine, this leads to an important identity that we'll use a lot in trigonometry. It's called the Pythagorean identity. It says that the cosine squared, that's x squared, plus the sine squared, that's my y squared, x squared plus y squared equals 1. And so I have a identity that if I know sine or cosine, I can solve for the other one by solving this equation. I also want to just make a note that the notation that's used in trigonometry, where I have the power on the function, really means I'm taking the cosine of the angle, that's a number, and I'm squaring it. And I'm taking the sine of an angle, that's a number, and I'm squaring it, and I get 1. But trigonometry often uses fewer parentheses than you would normally expect, and so the parentheses are dropped and the powers move to the function. I'm not sure it's a good notation, but it's so common that you need to know about it. All right, so I have some unit circles left down here. I want to talk about a couple examples so that we can think about where they are. So let's do our first example. We're going to look at the angle theta equals pi over 4. And we learned earlier that this corresponds to a 45-degree rotation. So if I thought about starting at my initial point, 45 degrees corresponds to this point. And so I am at an angle pi over 4. Now, the thing that's important about a 45-degree angle is that the triangle that I form with 45 degrees, these two legs of the triangle are equal in size. So I can use the Pythagorean identity. If I know that my x and y coordinates are the same, I get x squared plus y squared equals 1. And if x and y are the same, I get 2x squared is 1. My x coordinate and my y coordinate are both equal to the square root of a half, which means that I know this point is the square root of a half and the square root of a half. Now, often we want to simplify the notation there. This is a perfectly good way of writing this, these coordinates. So for example, we would normally not leave the 1 under a square root. And due to historical things with slide rules, often we want to eliminate these square roots in the denominator. So I'd multiply top and bottom by square root of 2, and I get square root of 2 over 2 for both my x and my y coordinates. I'm perfectly happy with either of the top two. Okay, so the x coordinate is the cosine, and what that means is my cosine of pi over 4 is equal to the square root of half, or 1 over square root of 2. And the sine of pi over 4 is also square root of a half. Okay, the second one I want to focus on is the angle of 90 degrees. So that corresponds to pi over 2. 90 degrees corresponds to a point where I've traveled an angle of pi over 2. Now you can see that by traveling this far, I've moved from being on the x-axis, now my point is on the y-axis, and so I'm at a point 0, 1. I don't have to do anything special. The x-coordinate is my cosine, so I get the cosine of my angle. Cosine of pi over 2 is 0, and the sine of pi over 2 gives me my y-coordinate, that's 1. Okay, for our last example, let's look at an angle that's negative. So I'm going to look at an angle that's negative pi over 3. So this is negative 60 degrees. Because I'm going in the negative direction, I'm going to be going clockwise, and 60 degrees is about there. So again, this is a right triangle. The x-coordinate and the y-coordinate, when I'm at 60 degrees, it's half of an equilateral triangle. So the other half is sitting here. And what that means is that my x-coordinate is at a half. So x equals a half. And how would I find the y-coordinate? Well, my y-coordinate comes from solving the Pythagorean identity. X squared plus y squared equals 1. And I know that x is a half, so when I square it I get a fourth. Solving for y squared, I get y squared equals 3/4, and I get y is either positive or negative square root of 3/4. The way that I decide if it's positive or negative is based on where I am in the graph. So because I have gone a negative angle, at negative 60 degrees, I'm below the axis. My y value is negative. So I choose y equals the negative square root of 3/4. 3 is not a perfect square, but 4 is the perfect square of 2. My y value is negative square root 3 over 2. Consequently, I have my coordinates. The cosine of negative pi over 3 is a half, and the sine of negative pi over 3 is negative square root 3 over 2. Now, in high school, it's often taught on the unit circle to just memorize the angles of 30, 45, and 60 degrees all the way around the circle. I don't find this to be particularly helpful. It's more important that you understand how the unit circle is related and how the x and y coordinates can be found from the equation x squared plus y squared equals 1.